Hello, and welcome to this Tungsten Cluster Masterclass training session where we take a deeper look at multi-cluster topologies, specifically Composite Active-Passive. My name is Chris Parker, VP of Customer Success here at Continuant. So in this session, we'll start by reviewing what the Composite Active-Passive topology is and how it works. We'll discuss any additional considerations and review the configuration files to build the topology. I'll finish with a demonstration of the topology being installed. So let's look at the topology to start with. So the Composite Active-Passive cluster builds on the foundation of the standalone cluster for HA and adds in the benefit of DR. So in this topology, you would have at least two clusters of the same minimum requirements of 3 nodes per cluster or 2 nodes with an active witness. One cluster would be configured as the active cluster. The other cluster or clusters would be passive. Within the active cluster, you would have the primary node that takes all of the write traffic. Replication then flows down to the local replicas and across to the other clusters via the relay node, which will then distribute down to its local replicas. The connectors will ensure all the write traffic is sent to the active cluster accordingly, regardless of which cluster the connector is primarily associated with. Additionally, all reads can then be distributed across any node in any cluster, not only providing the HADR, but also expanding the availability of your data to applications and clients that could also be geolocated, putting the data closer to your customer. Whilst failover between nodes within a cluster is automatic, should the active cluster fail completely, then an operator would manually promote one of the passive clusters to be the new active cluster. This process is manual by design to ensure that failovers do not happen under false conditions, especially important for geo-distributed clusters where the network latency may be high. The benefits of this cluster topology provide you with distributed DR, be it local, within the same region, or across continents. For global read-heavy applications, this topology can place your data closer to your clients. So what are the configuration considerations? As with a standalone cluster, all of the usual prerequisites that we covered in our earlier sessions need to be in place. For network connectivity, not only do you need to ensure local cluster nodes can communicate, but you also need to ensure they can communicate across regions. This could have additional security considerations within your organization and should be handled accordingly. A full list of the network ports required, along with all of the prerequisites, are listed in our documentation, or you could review the earlier training sessions which cover this in more detail. You need to ensure that network latency between clusters is adequate to ensure timely replication. Whilst we do not have a documented minimum latency expectation, you should be aware of the implications of high latency. Finally, connector behavior. As discussed on the earlier slide, all the connectors will always route right to the primary node in the active cluster. Read behavior can be configured differently, by default distributing reads to the local cluster associated with the connector. However, this can be changed with the use of affinity and advanced routing methods. I do not cover these specifics in this course, however there is extensive documentation online at docs.continuant.com that will guide you along with our extensive support services as well. So what does a configuration for active-passive look like? Well, first of all, there's an example of the configuration file here on the screen. This is the configuration file that I will use in my demonstration shortly. One cluster is identified as the active cluster. So in this demonstration and this example, the alpha cluster is the primary active cluster. And then all other clusters are passive clusters. So this example only has one passive cluster, which is beta. And you can see within there we have the relay source line, which points to the active primary cluster. You'll also see the difference in the beta cluster where relay is DB4, whereas in the active cluster we have master equals DB1. The relay node, whichever relay node is active during a switch, would become the primary node or the master node if that particular cluster was promoted to be an active cluster. The relay node also automatically fails over in the same way as a primary node, so should the relay node DB4 fail, one of the other nodes within the beta cluster would be promoted and all of the various connectivity would be updated accordingly, and I will show you that in the demonstration as well. So moving between the primary node to any passive cluster, it's a single switch command. As I said earlier on, that failover between the alpha and the beta or the active and the passive clusters is not automatic, and that avoids that network flapping if the network is unstable or there are any issues. And that helps to avoid split brain. And that can be a very simple operation to switch between the clusters. I will show you how that works. So let me switch screens and we will go through the demonstration of how to install an active-passive cluster. Okay, so on here, currently I'm showing connections to DB1, DB2, DB3, and then on a different window here, I have DB4, 5, and 6. So first of all, let's look at the configuration file. So I'm issuing this command to all nodes at the same time. And you can see here we have the configuration here, so the default section. So this is the settings that apply to everything. I've gone through this before with the standalone cluster, so I'm not going to go into a lot of this in great detail, but just a few things to point out. In this example, I've disabled bridge mode for my connector, and I've enabled a read-only port here for port 3307. So this is just setting up the read-only port, the port-based routing for the connector. I'm also disabling security controls. It's just for simplicity for the demonstration. And then we have the various API properties being enabled and the credentials for the API. I'm not going to demonstrate the API in this session, but these are just standard default settings to enable the API in version 7 onwards. I then have definition for the alpha cluster. So the topology is clustered, the primary node, and and all of the nodes that form that cluster, so DB1, DB2, DB3. For the purpose of this demonstration as well, I'm also installing the connectors on the same host as the databases. As we've discussed in previous sessions, you wouldn't do this typically in a production environment. You would want these connectors to be on dedicated connector hosts, but I'm doing it here for the demonstration just for simplicity. Then we have the beta cluster. Again, topology clustered. In this case, relay equals DB4. The members list, again, listing all of the nodes, and the connectors listing all of the nodes. And then the relay source alpha. So where does this cluster get its replication from? It will get it from the primary, the active cluster. It's important to note the connectors here, so DB1, DB2, DB3 are associated with the alpha cluster, 4, 5 and 6 are associated with the beta cluster. However, because beta is a passive cluster, any writes that go through connectors 4, 5 and 6 will route through to the alpha cluster. Reads within 4, 5 and 6 will be distributed across the beta cluster. So it would read locally, write to the remote. And then we have the final section, the global section. This creates a global definition within the cluster. It's like a cluster of clusters, and we're calling this global, and we're saying that this global cluster is made up of these composite data sources, which is alpha and beta. Okay, and we have that same configuration file on the DB4, 5 and 6 as well. So the first thing I'm going to do is install the software. So if I go to opt continuous software, I have the software packages downloaded. I've got a few on here from various installations, but I'm going to be installing the latest version 8.0.1 for the purpose of this demonstration. So I'm going to go into clustering 8.0.1, and I'm simply going to do a tools tpm install. And while that is running, I'm also going to go to 4, 5 and 6, continuous software clustering 8.0.1, and I will do the tools tpm install there as well. This will bring up a bit of information. So SSL certificates have been auto-generated, and that's because I have SSL enabled for the API. If I had security enabled for the cluster, the same process would happen, the same certificates would be created. But in this instance, for my installation here, these certificates will just store the credentials for the API. The cluster is installed, so it's saying the next steps. I can start everything, and then I can use ccTRL, and there's a little bit of information there about backups if it's of use. We just look at 4, 5 and 6. The installation there is complete as well. So two things. First of all, you need to reload your environment. You could either, as the output suggests, source the bash profile, and that just reloads the environment, sets up the paths and various aliases. What I like to do, keep it simple, I just log out and log back in again, and that will do that environment reload for me. And I will just do the same over here. And now I can start all the software. So I'm going to do a start all. I could individually do connector start, manager start, replicator start, but this is the first time I've installed everything. I want everything running, so I'll just use the shortcut start all, which will start all of those components for me. So we'll kick the start all off on the active cluster, and then we'll go to here, and we'll kick the start all off over here. Now what's important to point out at this point, This is a fresh installation. It's a clean install of MySQL. I don't have any data in MySQL, it's just the basic installation. If you were putting this onto a system where you already have data, then you would need to go through some backup and recovery options. You would need to precede all of the nodes with a copy of the database from the primary node. So you would take your primary node with your data in it, you would take a backup of it at a known point, you would restore that backup on all of the other nodes, and then you would install the software. There are a few other steps. I don't go into detail in this session. We have backup and recovery sessions, which will talk about all of those approaches and those methods. So just for the purpose of this is a clean, brand new installation with no data in it as yet. So everything has started up. All the software is running. So now I'm just going to switch to running on one node at a time. So DB2, let's look at ccTRL. As I mentioned before, ccTRL is our cluster control tool. And this can be issued from any node within the topology. And you don't have to run it from the primary node, it can be run from anywhere, and it will always give you the correct view. Now I'm on DB2. DB2 was part of the alpha cluster, so by default it has connected me to alpha. So if I do an ls, let me just move this window wide a little bit here. So we can see that DB1 is the primary, DB2 is a replica, DB3 is a replica, everything is online, and that's good. If I switch over here to DB5, DB5 was part of the beta cluster, and so therefore it's connected me to beta. If I just open this up a little bit more for you to see, so we can see that DB4 is the relay, 5 is a replica, 6 is a replica. So the difference in here is for the relay, if we go back to the primary node, so the DB1 is the primary, replicator is the role of master, it's online, and its replicas, the replicators, running as replicas, and they're connected to the primary node, to DB1, so they're getting replication from DB1. In the passive cluster, DB4, the relay, it's getting its replication also from DB1, and it's a role of relay. So it's pulling that replication across the network from the remote cluster. The replicas within this passive cluster are then getting its replication from its own local node DB4. So the flow is from active DB1 across to DB4, then DB4 down to DB5 and DB6. You mentioned we have the cluster called global, so if we can actually use global in this case as well. And this takes us up one level, and then we can see a view down to both of the clusters. So here we see alpha is the composite master and beta is the composite slave. So this is the active and this is the passive cluster. And you can jump also, although we're on the beta node here, we can also jump to alpha, and we can jump around. So we can move around clusters within this entire topology. Okay, so first of all, let's go to DB1. So DB2, the active cluster. As we can see, DB1 is the primary, so I'm going to do a switch. I want to move DB1 to a different node. The first thing we do is any sessions that are active, we will wait for them to finish, and then we'll make sure replication is up to date, and then we'll choose the selected replica. So in this case it is selected DB3 as the new primary node, and that selection is based on a number of rules based on latency. Obviously my cluster here is brand new, there's no applications, there's no data running through it, but if there was a lot of data running through it, the selection, it would look at these latency values and make sure it chose the most up-to-date replica to bring online. So the switch is completed. If I do an ls on here, I see that DB3 is now my primary. Now if I look at beta, so DB4 is the relay, DB4 still is the relay, but we see this time we've automatically updated to for DB4 now to pull its replication from DB3. Within the passive cluster, the switch can also occur, and that will move the relay node. So in this case, DB4 was the relay, it's now selected DB6, and when this switch is finished, you'll see that DB6 now becomes the relay. Just wait for that to finish. There we go, that's complete. And we see that DB6 is now a relay, and it's still updated so that it's pulling from DB3. So all of the switches, the commands, they still work. You can still do shunning a node if you want to do maintenance, but this particular cluster is only going to be receiving reads. So as I've turned bridge mode off and I've set my cluster up in what we call port-based routing, I need to make sure that my user map is up to date so that my applications can connect. So let's just do that first. So first of all, I just need to go to the primary active cluster. So on here, I've created a user. So I'm just going to connect to MySQL first, go through the connector. And just select that host name. So we can see we're connected to DB3, and we know that DB3 is the primary because we did that switch and all of that moving around. And I'm just going to select user host from MySQL.user. So I created this demo user earlier on. So for this demo user to be able to connect through the connector, because I've enabled port-based routing and I've disabled the bridge, mode, I need to put this user into my user map file. So this is something I need to do on every host in both clusters. So first of all, opt continuant tungsten connector conf. And we have a file there called usermap. So first of all, down at the bottom here, a lot of examples, and then there'll be an example here called app user. So the app user that you have in your configuration by default is added in, and I'm just going to add a new line here, and I'm going to put my user in. So insert demo user. So what this is saying is this is the username and password for my demo user. Global is the composite cluster, and then alpha is the local cluster that we want the affinity for that particular user to be connected to. Come out of there, and then we need to do the same on DB4, 5, and 6. Oops. Continuant tungsten connect conf by the user map. And here you see the line is slightly different. Here it's got beta at the end because these connectors are associated with beta. There we go, pop that in there. So now that user can connect through the connectors, take advantage of port-based routing. So how does this work? Well, let's go on to DB5. So DB5 is a relay node, and we will do first of all let's go to the active cluster. So on the active cluster, DB3 I believe is our primary node, so let's just double check that, and yet DB3 is our primary node. Okay, so if we do a MySQL connection, and we'll use demo user and our password, and we're going to go to the host, and we'll connect through the connect on DB1, and we're going to go to the port 3306. Okay, so I've got a connection into MySQL. If I select at hostname, we can see I'm actually connected to DB3. So I've connected to the connector on DB1 port 3306, and it's saying 3306 is your primary write port, therefore it's routing me through to DB3. Okay, so all writes will go through DB3. If I change my port number to 3307, because I've enabled the port-based routing and I've enabled 3307 as my read-only port, that same routing to the port 3307 through the same connector, in this case has taken me to DB1, so it's taken me to a replica. And the reason I'm showing you this is to show you how the connectors work in the active-passive environment. So that was using the connectors on the active cluster. If I now switch to the passive cluster and you have an application, say, for example, let's say this passive cluster is situated in Asia, your active cluster is in the US. You have clients in Asia who are doing quite a heavy read-based application. So if they connect into the cluster and they connect to a connector on one of their local cluster nodes, so in this case, let's go through the connector on DB4, but they also they need to do a write, so they need to make some changes, so they will go to 3306. Okay. And we can see they've actually gone through to DB3 because they want to do a write. DB3 is the only node within the entire topology that can take writes, so that connectivity has routed through to DB3. However, they want to do some reads now, they want to do some reports on their local data, so they'll connect to 3307, and this time they're connected to DB5, to one of the read replicas within their cluster. Okay, so it just shows that reads can be done locally, writes will go remotely, and obviously any switches and failovers, those will move as well. So the final thing I wanted to show you is what happens if our alpha cluster, our active cluster, is completely destroyed. The network is completely broken, the data center is blown up, whatever has happened, and you need to promote the passive cluster to be the new active cluster. You would simply go into ccTLR, and this time you would connect at the global level, so you would move up to the top of the chain, sit in that global composite view where you can see you have the composite active master, composite slave, so the alpha and the beta, and simply issue a switch at that point. And what this will do is we'll just switch those roles around. So it will make beta the master or the active cluster, and it will make alpha the composite slave or the passive cluster. This takes a little bit of time. What it's doing here now is the relay node in beta is now becoming the primary node, and the primary node in alpha is becoming the relay node. So if we now go to beta, DB6 was the relay node, DB6 is now the primary node, and that is where the writes will go. And if we look at alpha, DB3 was the primary node, and DB3 is now the relay node. And just to show that again from the connectivity point of view, that same connection in beta that originally went to DB3 in the alpha cluster, because we're going through port 3306, if we do that connection now, it's now routing to the primary node, the new primary node, which is DB6 within the beta cluster. Okay, so that's a very simple installation of an active-passive cluster, a simple demonstration of how the connections from the connectors will work and will move based on the roles of the primary nodes. So that concludes this particular training session. So what have we looked at? Well, we've reviewed the multi-cluster topologies, in this case the composite active-passive. We've looked at the architecture of that topology, the difference between the primary node, the relay node, the active cluster, the passive clusters. We looked at the configuration differences, and then I did an installation and showed you how that worked. So thank you for taking the time to listen to this session. I hope you found it useful, and I hope to see you again soon on one of our other training sessions. Thank you and goodbye.